Hello everyone. Today I am back after a long time continuing with my C programming language session. So last time I left on the streams part when we were trying to understand how streams work and how we can work with files, different sort of file handlers in C programming language. So let's try to revisit it once. Then we will start today. We are planning to work on basically multiple source file. How can we create header files? Because if you can see today, we till today we have wrote all of our code in a single C file. But today, what we are trying to do, we will now create multiple header files inside our code base, and we will import our code, different functions from that header file into our new code file. So first, leave where is it? What last time we were doing, we were writing some streams program. So in that streams, so what we were doing, so we have a in.txt file, input.txt file, and inside that file we can write hello viewers who are coder stream. So what we have discussed is we can take an input from any file and stream back into another file. For example, if we are going to cat in.txt, then we can use pipe to count the how many words are there. So this is piping. This takes the standard output and pass it to the standard input of another program, and that program calculates number of characters in there and prints 41. So now we will try to write a code with also that code will also include some sort of flags. So first what we will do, we will include std standard input output dot h. Then we will create a main function. Inside that main function, we know that there are two arguments. First is argc, number of arguments we are passing, and second is argv, the pointed by array, return 0. And then now what we have to do is first let's assume we will create a pointer file name. Okay, and then we are going to take we are going to understand, for example, char ch, and this ch will basically read the option as an argument which the user is inputting from the command line argument. So for example, I have turned off. First let me write open the tmux. Okay, then let me open now again streams. Sorry, what happened? I don't know what happened. Where did the code go? But okay, we will write stream.c. Okay, rm stream tree.c. Yeah, fine. So what I'm saying, for example, there is a wc dash c. So dash c, we will pass also this dash c option in our program. So in order to get that, what we can do is we can create a while loop, and inside that while loop, our character will read the get option, get opt, and this as we read last time was is present in unistd.h. This is the header file, and today we are going to discuss how can we create this header file get option, and then we want to understand now. So I don't remember what this how this get option works. So what I can do is I can go to get opt man page. So get opt man page and then try to understand. So this get opt first takes argc, second it takes argv, then it takes the options we want to pass. So as simple as that. First it takes argc, and here I've done a take argc, and then it takes argv, and then it takes the options which we want to pass. So first option is, for example, if we want to print to directly to the standard output, and if we want to print to file, and colon defines that we are going to take an argument of f. Okay, and this is get option, and we have to mark it is not equal to 1 until unless it is not equal to 1, and for this int we will mark it as int. Okay, last time it was not working, and after debugging, yeah, I do remember that we were using it as character. If you look at the last video, we were using it as a character, but today, but after some time I fixed this and checked that if this must be an integer. And okay, now we have that character. So now we can perform a switch case over that character, and in case we can mention what could it be, what this character could be. Either this character could be s, and if it is s, what we are going to do, we are going to keep file name as empty string, and sorry, and then we will break the code. And then if the case is f, then file name is equal to so this is the file name get option. Then we check the documentation. How can we get the option? So it is mentioned that opt arg. So you can see that this opt arg will help us to get the argument. Opt arg will help us to get the argument file name, and then break the code. And if it goes to default, then we print uh, then we will print to the stderr, and for that I printf stderr comma, what we are going to print is please enter value flag backslash n no column, and then we are going to return. That is fine. Then perfect. While block is empty here. Now we have a list of options. For example, file name. We have a step. Now first we want to calculate whatever program will do. It will work like wc-l. It will read the characters of that file and displays it on whether stdout if flag is passed, and if a flag is passed, then will it redirects that output to a file. So first our job is to read the number of characters of the file. So we have a basic input file. So const char pointer put file name, which is equal to in.txt. Okay, now we have to read that file. So in order to read that file, what we can, so we will create a file pointer in file, and then we can use fopen, and in fopen, so rather than, so what we can do is, rather than reading from the file, we can, one thing we can also do is we can cat the in.txt and take the input from the standard input rather than directly from the file. So we will delete this. What we can do is we can read the number of characters that are being present on the standard input. Our input will always be the standard input rather than a file, and the output will be dependent upon s. So do we remember how can we read standard input? Yes, the help of fscanf, and in fscanf we have to mention the stream where we want to read from. Can also work in case of file, but here we are printing fscanf, and then we are going to pass it what we want to read. And for that, first which uh, buffer we want to read. So we will create a char buffer. Length of the buffer 200, not more than 200 characters, and we are going to read first 199, but we won't include backslash n. Okay, and then we are going to read to the buffer. It will automatically read to the buffer. Now we have to calculate the number of digits that has been written for buffer, characters that has been written for buffer. So what we can do, first we can create a pointer to a character. Let us assume uh, counter counter, and it will store the address. And obviously counter equal to buffer. Buffer. What does buffer return? Buffer return the address of this uh, array of characters. Array of characters. So counter will store the starting address of it. Now we have to till the value of counter is not equal to centillion character, because centillion character is a termination character, and what we have to do, we have to keep on incrementing counter plus plus. We can create int size 0, also give size plus. So this will get the size. Now size is fine. Now the second thing is we have to compare if file. Okay, so for that we can use hash include string.h. Yes. So here what we can do is we can compare str cmp compare if the file name is equal to empty. File name is empty, then what we have to do? We have to print f directly to std out, and what we want to print length of the stream person d comma bachelor and very important comma size. Okay, that's what we wanted to print. But else that is not the case, then what we want to do? Create a file pointer out file, and then we will open that file. And so let's go to the document man page of the open. We'll try to understand what open mentions. It takes the path name and it takes the mode in which we want to read. So we want to write mode, basically append mode. Is there some example how to the modes? Yeah, so these are the modes. So these are open flags, these are f open flags. If you are using f open mode, then you can mention these. If you are using open mode, then you can use. So append, uh, read write only. So we will use append, or we can write whatever we want. Try with append, f open. So the first was the file name, and file name was file name, and the second one was the mode in which we are going to open. And if we, what was it? Constant character pointer. So character pointer, that means it was a string. Okay. So we have now out file. Now what we want to do is we will use same printf, fprintf. Then rather than using std out file and out file, then we have to print the length of the stream per the files, and then we have to close the file. F close out file, as simple as this. So here now what we can do, we can see dash o stream dot c stream dot dash o str. So there is some error first. Or not of error. Oh, sorry. This is an take is there. So the pointer here to again compare. So the first one is gone. The second one. So it is F scanner. Okay. So let's try to see what is the documentation of F scanner. F scanner. F Then it is file pointer format. File pointer format. I think the name buffer is not right. So buff where you want where you want to read. First is pointer, file pointer, stdin is file constant character file format. Buff undeclared. Oh, oh, sorry. Semicolon was okay. Now counter is equal to buffer. So buffer is fine. Right. Ah, now strcmp. Two five arguments to function strcmp. Okay. So what is the mistake? Here is the mistake. The compare. So file name, file name, file name, comma. Yes. Now it is now it is built. Now str. And what we have to do? We have to take the output from in.txt here from the text, and rather than writing to the standard out, it will write to this file, and then what we can do here is pass dash flag and segmentation called dumped. Dumped. Okay, okay, sorry, cat in.txt, and we want to from here dot cat in.txt. I'm passing out .txt, then it is printing the error. If trying to compare file name, in compare file name, the file name pointed to a string, pointed to a character which is not be a basically a string dash f flag is out of the file name. Okay, so let's check the back of OPT as character, and the problem is file name rc mine I don't think mine equal to OPT because this will only decrement the RC and R, but we are not using it. So when we counting the character, the length it is counting perfectly, but it is not able to write properly. We are writing file name out file is file name. File name we are passing dash f flat file. So let's put file out.txt. So file name is absolutely correct. File name hmm. The problem is code comparison. If string comparison is something which we are not doing correctly. String in file is strlen file comma cr if file name. Okay. Now I'll get to out.txt. It is working. The problem was with string API. I'm not how string is it works, but and we are comparing the file name and length of the file name is 0 because nothing is passed and it's working fine. Now the second question arises, what if we are passing cr dash s? Now it is also fine. Now it is now we just have put stock for again the and again at out.txt because we have in appended mode, it will append to it and if we dash s into the stream, let me do data add paragraph sequence yeah, not rm. It is fine now. Okay, so now our chapter is done. Now go to chapter 4. Chapter 4. Now we will chapter 4. Let's continue with chapter 4 now. So in chapter 4, what we are going to study now. So if you create a big problem, you don't want a big source file. Can you imagine how difficult and time consuming a single source file for an enterprise level program would be to maintain? In this chapter, we will learn how it allows us to break source code into small manageable chunks and then rebuild them into one huge program. Along the way, you will learn a little bit more about data type fatalities and get to beat your best different make. I have been trying to learn make for a long time because it is not only usable for C programming language, it can be used for other programming languages like Golang also. So hopefully I will be better at C after completing this chapter. Better at make, sorry, after completing this chapter. Yes, the data types. C can handle quite a few different data types as we have studied. We have seen different data types like int, pointer to character, pointer to file, character, whole number, floating point values, and floating point number for really precise scientific calculation. You can see a few of these data types listed on the proposed page. If you can figure out which data type was used in each example. Okay, try to float, double, short, long, int, char. Character. Each character is stored in the computer memory as a character code, and that is just a number. So when a computer sees A to the computer, it's the same thing, the little number 65. So basically, these characters are being uh, stored in the ASCII format. So 65 is the ASCII code for A, and that is what computer tries to understand it. Next is integer. We have used it along our code base till now. The exact minimum size of int can vary, but it's guaranteed to be at least 16 bits. In general, an int can store up to a few million. Short, but sometimes you want to save little memory for using int, so we can use a short if you want 2000 or hundreds. Long, but if you want to store a really large count, that's when we'll use long, and it can hold up to 1 billion in data. Float. Float is the basic data type for storing floating point numbers. For most everyday floating point numbers, like the amount of fluid in our orange, cappuccino, float, and double. But what if you want to get really precise, accurate, large number of decimal places we want to use, then we can use float. Don't put something big into small. They are saying if you have tried to put an int variable into a short or long variable into an int, then there are chances of data loss. So different data types use different amounts of memory. So you need to be careful that you don't try to store a value that's too large for the amount of space allocated into a variable. Short variable take up less memory than ints, and int takes up less memory than longs. Now there is a problem storing a short value inside an int or a now there is no problem when we try to store a short value inside a long variable or an int variable because there is a plenty of space. The problem starts when if you go the other way. If you try to store an int value into a short, then our memory will be lost. Sometimes the compiler will be able to spot that you are trying to store a really big value into a small variable and give you a warning, but a lot of time the compiler won't be smart enough, and this can cause a lot of problem. The computer will fit as many ones and zeros as it can, but the number that stored inside the variable will vary different from the one you sent it. Okay. So there are two type of values, signed integer and unsigned integer. So why did I putting a large number into short so negative? Numbers stored in binary. This is what 100,000 look like in binary. But when a computer tries to store that value into a short, it only allows the value a couple of bytes storage. The program just stores the right hand side of the number. It only stores this value. Signed. Values in binary begin with 1. So negative values begin with 1. So this is for the value to understand sign. So if 1 is it is negative is 0, it is positive 1, and then it calculates this. So it will become negative 310. Using casting to put floats into whole number. So int x equal to 7, int y equal to 2, float z equal to x by y. 3.0. Why is that? Because we are dividing two integers and then we are converting it to float. So 7 by 2, the value will be 3.5, but 3.5 could not be so because we are trying to divide two integers. Value will be 3, and then it is converted to float. First we have to convert that into both of these items into float, then we have to store it, or first or any one of them, then we have to store it. Unsigned. Unsigned means uh, the number will always be positive because it does not need to worry about the recording negative number. Unsigned numbers can store large numbers since they have one more bit to store. So an unsigned int stores numbers from 0 to a maximum. So we can use unsigned long double D. You can prefix a data type with a long and make it longer. So a long int um, so a long int is longer version of an int, which means it can store a larger range of numbers. And a long is longer than long, which is very confusing. Okay, so we don't need to understand all of these. So it's a simple type of data types. So let's try to move forward with it. Okay. So what are the types of operating on different operating systems? We use different data types on different operating systems and processors because that allows it to make most out of hardware. So when C was first created, then at that point of time, most machines were 8-bit or most 32 and 64-bit because C does not specify the exact size of its data type. It's been able to adopt over time, and as newer machines are created, C will be able to move them. Technically, the bit size of a computer can refer to several things, such as the size of the instruction or the amount of data the CPU can read from memory. This is a very important point. We have been understanding that there are 32-bit CPU, 64-bit CPU. So we are trying to make it the instruction it can size of the instruction, the amount of data that it can read. The bit size really the pivot size of numbers that the computer can deal with. So what do we have to what that have to do with number? The computers often best to work with 32-bit numbers and the basic data type. The int is set as 32 bits. I understand how float numbers like int work, but how are float and double store? How does the computer present a number with a decimal point? It's complicated. Most computers use the standard published by the IEEE. Complicated. No, the vast majority of developers use floats and doubles without worrying about the detail. What happened to the code? So it is related to pointers and conflicting types for add with type. Let's try to see total float var printf value item scanf percentf value will equal to 1. This scanf, what it is trying to say, I don't understand to be honest. So correct order. So let's see creating the first other method code. So you have added a new cool function to your code that everyone thinks that is a fantastic. Let's start from there. In do whatever, we have created a function, flow do something in do stuff. Whatever happens, what happens if you then decide your program will be even better if you add a call to do something fantastic function in the existing do whatever code. You will have to move the function earlier in the file. Most coders want to spend their time improving their code, improving what their code can do. It would be better if you don't have to shuffle the order of the code just to keep the compiler happy. It is most obvious because if we have some function, we have to move it before another function if you want to use it inside that function in C programming language. Situation there is no correct order. Okay, so this situation is rare, but occasionally you might write some code that is mutually recursive. Ping, pong, pong, ping. If you have two functions that call each other, one of them will always be called in file before it's defined. For both of the reasons, it is really useful to be able to define function in whatever order is the easiest time, but how? So we can create a declaration from the definition. Remember how the compiler made a note to itself about the function it was expected to find later in the file. You can avoid the compiler making exception by explicitly telling it what functions it should expect. When you tell the compiler about a function, it's called a function declaration. The declaration tells compiler about function, what return value to expect. This is a full declaration of a function. This is not a definition, this is only a declaration. The declaration is just a function signature, record of what function will be called, what kind of parameters it will accept, what type of data it will return. Once you have declared a function, the compiler won't need to make any assumption. So it won't matter if you define the function after you call it. Absolutely not. So if you have a whole bunch of function in your code and you don't want to worry about their order in the file, you can put a list of function declaration at the start of the program. Amazing. So we can use float, do something fantastic, double awesome to dot, int, stinky, pete, cat. So we have only defined the function signature. But even better, C allows you to take that whole set of declarations out of your code and put them in a header file. You have already using header files like stdio, std, lib.h, even std.h. So how can we create our own header files? So we can create a new file with .h extension. So let's do it. Then add text.h. Okay. Then create a file called uh, so it has called as totala.h. So .h. And then so we just have to add the signature and the argument it takes. Okay. Include a header file in your program. DOTALLER. When you write the name of the header file, make sure to surround it with double quotes rather than angle brackets. Why the difference? When the compiler sees an include line with angle brackets, it assumes it will find the header file somewhere up in the directories where your library code lives. But your header file is in the same directory as your C file. By wrapping the header file name in quotes, you can compare to look for a local file. This is very important point. Okay. When the compiler reads the hash include in the code, it will read the contents of the header file just as it had been typed into code. Separating the declaration to a separate header file keeps your main code a little shorter. This is total.c dashboard totaler. So, okay, but how did it happen? Okay, so it was related to something about I have declared a signature there, and let's say we have a main function. Okay, and the main called add with tax. For example, add two numbers. Int x equal what we can do int int x y equal to 3. Then we will create a function called add with tax. What does it take? Oh, so rather than what we can do, toddler dot what we can do, and change inside single quote, and we can use int x comma int y. That is fine. Right quit to tax int comma int y. So return put x. We are going to convert it to float also. Then we can what we can do print f comma percent f comma add tax comma y. So return so expected before float. Put expression before float. So what we can do equal to x dot expected expression before float. What expression? Hello, not retention. Yesterday, potential. Expected expression before float. It's equal to what expression was expected. I still don't get it. But this time. So the point is, but what if I don't use then the compiler throws an error. As soon as I add this to Talas, the compiler won't. But the question why it was saying float conversion float z equal to float x by float. Oh, okay, 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 okay. Okay, okay. My mistake. I've been practicing Golang programming language. Float z equal to float plus now it will work. Yes. Okay, got it. So now let's move forward. The importance of header file we understand. When compile the code, the program will work. So, so the problem here, let's see. Hash into candidate code goes at day number 3 of a Mercury day in Earth and ask day. So the code will be the first signature int main, then we will calculate it and you can compile the code. So it is fine. Work. So I don't need to have declaration for int function, not necessarily unless you are sharing the code. More about its own int function. So this program float length of day Mercury Earth in days and hours. Okay, Mercury in days and R in Earth days. Okay. So R in Earth day float day and we have declared. You can compile the code. To display a warning, no. The program will work, yes. So here int is not declared, but you can compile the code. If display a warning, the program will work. There will be a warning because we haven't declared the R in Earth before calling it leaking, but still the program will work because it is talking about the int function. Okay, so here the float it will definitely not work, and here the length of the day variable should float. You can compile the code. Program will not work. So it is mentioned here. We'll see about it. Quickly speaking, the compiler just does the compilation. It converts the C source code. Confused. You talk about the compiler pre-processing. What does the compiler do? Actually speaking, the compiler just does the compilation step. It converts the C code into assembly code, but in a looser sense, all of the stages that convert the C code into the final executable are normally called the compilation. The GC will allow to control these stages. And the compiler is very smart. Reprocessing is the first stage of converting a C raw source code into working executable. Reprocessing creates a modified version of the source code just before the process proper compilation begins. Here code the pre-processing step. Read the content from the header file into the main file. That is also a part of the pre-processing. To take the code from the header file and push it to the phases of combat to make things more efficient. Okay. So, why some header files have quotes and other have brackets? Strictly speaking, it depends on what your compiler works. Usually, quotes mean to simply look for a file using the data path, and so it includes the name of the file. But if you are using angle brackets, then it will search for the file along the path of the directories. What it is, and earlier it was mentioning that it is going to read from the code where our libraries are present. GCC compiler knows on the standard headers are stored on a Unix style operating system. The header files and includes are normally in place use the local include and few others. So that's what it is talking about. It is trying to search for a along the path of that it is relatively from this path. Windows can also do that. Okay. Now, the reserved keywords auto, if, case, unsigned. These are reserved keywords. These cannot be used. Very very upset. So I think it is enough for today. I will try to do the stream daily and read, try to learn daily and daily because we have to go to 400 more pages. Only 200 have been done, and things are going to get complicated later. So we are currently on chapter 4. Here, if you have common features, so we will try to complete it tomorrow. Then we will go to structure and data structure, and there is lot of things to learn. So thank you.